Welcome to Crystal Clear Chemistry channel. In this video, we are going to discuss about the basics of the ionic equilibrium as part 1. In order to crack either JEE mains or NEET exam, let's strengthen our concepts of chemistry of class 11 and class 12. And in this video, we are going to discuss about the ionic equilibrium concepts, the part 1. I have already done the chemical equilibrium. You can check the playlist, and in those videos just a little bit voice noise is there, so just bear with it. Definitely you will be benefited by watching those videos. Without any delay, let's get into the first topic of ionic equilibrium, that is what is meant by ionic equilibrium. If we consider the electrolyte, what is meant by electrolyte? The substance which conduct electricity in the aqueous solution, nothing but electrolyte. And those which do not conduct the electricity in the aqueous solutions are nothing but non-electrolytes. And electrolytes are of two types: strong electrolytes and weak electrolytes. Those which dissolve in the water or ionize in the water completely, nothing but strong electrolytes. Weak electrolytes are partially dissociated. Hence, those weak electrolytes readily exist in equilibrium with that of the. So, if we consider the weak electrolytes, there exists equilibrium between the ions and unionized molecules. What does it mean? Suppose if we consider a weak electrolyte like HA, when it dissociate in the water, H plus and A minus will be formed. As it is weak electrolyte, it will not completely dissociate, and moreover the dissociated ions come back to the original substance, and hence there exists equilibrium between undissociated substance and the ions. That is what all about the ionic equilibrium. You can see the ionic equilibrium especially in the case of acids, bases and salts. Okay. Now, suppose if we consider the non-electrolyte, they do not dissociate into ions on dissolving in the water like solvent like water. For example, if we consider C6H6, benzene, diethyl ether and all, they do not dissociate into ions and they can't conduct electricity. Hence, they are said to be the non-electrolytes. Now, if we consider the acids, bases and salts, no doubt they are the electrolytic substances because they can conduct the electricity. Depending upon the degree of dissociation, alpha, we can say they are the strong acids or strong bases or not. We know already about the degree of dissociation. If one molecule is taken, if it is completely dissociated into ions, you can say that the degree of dissociation is unity, and you can say 100% the substance is ionized. You can see the strong acids like perchloric acid, HI, HBr, HCl, H2SO4, HNO3, all these comes under strong acids. NaOH, KOH, RbOH, cesium hydroxide, barium hydroxide and all comes under strong bases, and these are the strong electrolytes too. Whereas the weak acids and weak bases, degree of dissociation will be less than 1 and they do not ionize 100%, and they are said to be weak electrolytes. And even some sparingly soluble salts like AgCl and BaSO4 etc. also comes under the weak electrolyte. Weak acids example acetic acid, HCN, and weak bases example ammonia, ZnOH twice etc. Okay, so these are all about the strong electrolytes and weak electrolytes, especially in the salt hydrolysis and the buffer solution concept. You need to know what are strong electrolytes and weak electrolytes. You need to by heart the examples of all these acids and bases. Okay, now let's move to the acid base theories now. Those
What
which
is
are
acid
which
base
do not
theory?
conduct the electricity in the
Is
aqueous solutions are
Arrhenius
nothing
acid base
but
theory. According to
non-electrolytes.
the Arrhenius concept, the
And
substance
electrolytes
which
are of two
readily gives
types:
H plus
strong
ion
electrolytes
nothing
and
but
weak
Arrhenius
electrolytes.
acid.
Those
We
which
know
dissolve
the acids, some of the
dilute
acids
in
like
the water
nitric
or
acid,
ionize in the
perchloric
water
acid,
completely
sulfuric
nothing but
acid,
strong
phosphoric
electrolytes.
acid, etc.
Weak
And
electrolytes are
depending upon
partially
how many
dissociated.
H plus ions
Hence,
can be
those weak
replaced
electrolytes
in that
readily
particular
exist
acid,
in
there are of
equilibrium
three
with
types:
that of
monobasic
the.
acid, dibasic acid, and tribasic acid. You can see the examples here.
So, if we consider the weak electrolytes, there
Similarly,
exists
if we
equilibrium
consider the
between the
H3BO3,
ions and unionized
H3BO3
molecules.
will not give
What
H
does
plus
it
ion in
mean?
the water,
Suppose if we
so it is
consider
not an
a
Arrhenius
weak
acid.
electrolyte
We can
like
check what
Ha,
type of acid it
when
is
we
later.
dissociate in the
And
water,
if we consider the
H plus and
HClO4,
A
it
minus
readily
will
gives H plus
be
ion
formed.
and combines with the
As it
water
is
molecule and
weak
forms
electrolyte, it will not
hydronium
completely
ions, and
dissociate,
hence
and
it is the
moreover,
strongest
the
acid among the
dissociated
known
ions
acids, the
come back
perchloric
to
acid
the
HClO4.
original substance, and hence there exists equilibrium between
Whenever the H plus
undissociated
ion in the water
substance
is
and
extremely
the
hydrated,
ions. That
along with
is
the
what
formation of
all
hydronium ion,
about
it can
the
even form
ionic equilibrium.
H5O2 plus, H7O3 plus and all.
You can see the ionic
And
equilibrium
high with the high
especially in
charge
the case
densities,
of acids,
you
bases
can check
and
here.
salts. Okay.
And if we consider
Now,
Arrhenius
suppose if we
base,
consider the
the substance
non-electrolyte, they
which
do not
releases the
dissociate
OH
into
minus
ions
ion, that is hydroxyl
on
ion in the
dissolving in the
water,
water, like
or you can say CC, the
solvent like
OH
water.
minus donor
For
is
example,
nothing
if
but
we consider
Arrhenius base.
C6H6 benzene,
Depending
diethyl
upon
ether
the
and all,
number of
they do
replaceable
not
OH minus
dissociate
ions,
into
there are of
ions
three
and they
types:
can't conduct
monoacidic
electricity.
base,
Hence, they
dibasic
are
base,
said to be the
and
non-electrolytes.
monoacidic base, diacidic
Now,
base, and triacidic base. So
if
if
we
only one
consider
OH
the
is present,
acids, bases and
monoacidic,
salts,
acidity is 1,
no doubt they
basicity
are
is
the
2 for
electrolytic
calcium
substances
hydroxide and barium
because they
hydroxide.
can conduct the
Similarly,
electricity.
acidity is 3 for ferric
Depending upon the
hydroxide.
degree of
Right? Here
dissociation,
also you can check the
alpha,
OH minus ions of the
we can say they are the strong
bases,
acids or strong
hydrated
bases
form.
or
You
not.
can clearly see
We know
here
already
with
about
the
the degree of dissociation.
exceptional high
If one
electron
molecule is
density.
taken, if it is
Okay,
completely dissociated
if
into
we consider
ions,
the
you
first
can say
group
that the
elements
degree of
except
dissociation is
the
unity,
lithium
and you
readily
can say
forms the
100%
strong
the
bases.
substance is ionized.
Now,
You can see
what is the second theory
the
of the
strong
Arrhenius
acids like
acid and
perchloric
base?
acid, HI, HBr, HCl,
Bronsted-Lowry theory.
H2SO4,
According to the
HNO3, all these
Bronsted-Lowry
comes under
theory, the
strong
substance
acids.
which donate the H plus
NaOH,
ion nothing but
KOH, RbOH,
Bronsted-Lowry
cesium
acid,
hydroxide,
H plus
barium
donor.
hydroxide and all
H
comes
plus
under
is
strong
nothing but
bases,
proton.
and these are
Why
the
it is called
strong
proton?
electrolytes too.
If we consider the hydrogen, it contains one
Whereas
proton
the
and one
weak acids
electron.
and weak
If we
bases,
consider H plus, by losing the one
degree of
electron only, it is
dissociation
converting
will be
into the
less
H
than
plus.
1,
That means it
and they
contains
do
only
not
one proton.
ionize
That is the reason why
100%,
H plus is called
and they are said to be
proton.
weak electrolytes.
So the
And even
proton
some
donor is
sparingly
nothing but
soluble salts
acid,
like
and
AgCl
proton
and
acceptor is
BaSO4,
nothing but
etc., also
Bronsted-Lowry
comes
base.
under the weak electrolyte.
And in this
Weak acids
Bronsted-Lowry
example
theory, the
acetic
important
acid
concept in
HCN,
the
and weak
entrance
bases
exam point of
example
view is about this
ammonia,
conjugate acid
ZnOH
base
twice,
pair.
etc.
Let us see what it is.
Okay, so
Suppose
these are
if
all about
HX is the
the
acid,
strong
if it
electrolytes and
loses
weak
H plus
electrolytes,
ion,
especially in the
it
salt
gives to the
hydrolysis
base
and the
like
buffer
B,
solution
so
concept.
that the base
You
B
need to
becomes
know
Hb plus
what are
and the
strong
acid
electrolytes and
becomes
weak electrolytes. You
X
need to
minus, right?
by
Now
heart the
listen
examples
carefully.
of all these
From acid
acids and
HX,
bases.
the X minus is
Okay,
produced.
now let's move to the
In the
acid
reverse
base
direction,
theories
it
now.
has the capacity to accept the H plus, to convert back to its original compound HX. As it is, as it can accept the H plus, it acts as a base, right? Then why it is called conjugate base? It is called conjugate base because if we consider the HX and X minus, They both differed by H plus ion. They both differed by H plus ion. The pair which differed by the H plus ion, in which one is acting as an acid, the other one is acting as a base, is nothing but conjugate acid base pair. You can see even the conjugate acid base pair here. For example, if we consider the B is acting as a base. After accepting the proton, it is converting into the Hb plus, and if we consider the Hb plus and B, only the difference is H plus. The one is acting as a base, the other is acting as acid. Hence, this is also said to be the conjugate pair, or you can say conjugate acid base pair. Okay, so here it is very important to be able to write the conjugate acid and bases of some of the ions. So let us see how to write the conjugate acids and bases. Okay, right. Listen here. Suppose if we consider the HCl, if H2O is the base, HCl converts into H3O plus, uh, sorry, HCl converts into Cl minus. So here HCl and Cl minus are the conjugate acid base pair, and if we consider the same reaction H2O and H3O plus, so here H3O plus and H2O acts as a conjugate acid base pair. Similarly, you can write the remaining pairs of these two also. Here let us see one of the interesting example. FeH2 of 6 times plus 3 plus H2O, if we consider, if it as it is acting as an acid, it should lose H plus. If it loses H plus, one of the H2O converts into OH minus, and hence you can see H2O of 5 and OH, and that H plus comes here, so that it becomes H3O plus. Okay, and the one more important thing is, suppose if we consider a strong acid, it has a weak conjugate base. Similarly, weak acid will have strong conjugate base. Okay, very important point. So let us see, let us see some of the examples here, how to write the conjugate acids and bases. For example, acid HCl. What is its conjugate as base? If they ask conjugate base, you simply remove H plus to get the conjugate base. The conjugate base of H2SO4, remove H plus, you will get HSO4 minus. Similarly, for a base, in order to get the conjugate acid, add H plus. This is the simple trick. To get the conjugate acid, for the base you add a H plus. For NH3, if you add H plus, you will get the ammonium ion. For H2O, if you add H plus, you will get the hydronium ion. So it's very easy to write the conjugate acid or base of the respective electrolytes. Then what are amphoteric or amphiprotic? Those substances which can act as both acid as well as base are known as amphoteric substances. If we consider the water, water can act as both acid and base, hence H2O is said to be amphoteric substance. Okay, now let's move to the third acid base theory, the Lewis acid base theory. According to the Lewis concept, the acid is nothing but the electron pair acceptor. So far, we discussed about the acid as a donor only, but for the first time, the acid is acting as a acceptor, and here the acid is accepting the electron pair, or you can say the lone pair from the other molecule or ion. Now, those substances which are electron deficient can readily accept the pair of electrons, hence they can act as the Lewis acids. If we consider the BF3, BF3 has
It's not a lone pair. Bf3 has a vacant orbital, so it can readily accept the pair of electron, even the AlCl3. Not only the BF3 and AlCl3, even if we consider the cations like H plus, Fe plus 2 and all, readily accept the pair of electrons, but not Na plus, I guess. Here they have mentioned a wrong example. So these two have the empty orbitals, so they readily gain the electron pairs. Hence, the cations with the vacant orbitals readily accept the pair. Hence, Lewis acids. Molecules with vacant orbitals like SOF4, PF3 and all also act as the Lewis acids. So, the one and only one condition, whether the molecules are electron efficient or electron rich, or the molecules with the complete octet also can act as a Lewis acids if they have the vacant orbitals. Very, very important. If we consider the sulfur, it is completely getting the stability by getting that octet configuration with that of the fluoride ions. But still, as the third shell is the last shell in the sulfur atom, as it has 3d orbital, 3d subshell contains the empty orbitals or the vacant orbitals, which are responsible for accepting the pair of electrons from the other substances, and hence the SO4 can act as a Lewis acid. Understand? So if they ask us to pick the Lewis acid, immediately we need to look for the vacant orbital. Now, what is the base according to the Lewis concept? The one which readily donate the lone pair of electrons is nothing but the Lewis base. Electron pair donor is the Lewis base, and especially NH3, PH3, H2O and all, in which the central atoms are having the lone pair of electrons, readily act as bases. They readily donate the pair of electrons, right? So here, if we consider the Lewis acid like BF3, it has a vacant orbital, and if we so this is Lewis acid, and if we consider the Lewis base like NH3, it has a lone pair of electron. We know already what type of bond is formed between these two, right? If the base is donating, the Lewis base is donating the electron pair, the Lewis acid readily accepts that electron pair and readily forms a coordinate covalent bond between Lewis base and Lewis acid. Understand or not? So, a dative bond is formed between Lewis base and Lewis acid always. And the formation of coordinate covalent bond or the dative bond is the neutralization according to this Lewis acid base theory. And not only that one, if we consider the Lewis acids, as they seek electrons, they are the electrophiles. As they seek electrons, they are the electrophiles. And if we consider the bases, as they seek the nucleus, the positive charge, you can call the Lewis bases as nucleophiles. As nucleophiles. Okay, so these are the some of the examples of Lewis bases and acids. And here you can clearly see there is a bond formation between the Lewis acid and the Lewis base, and in some of the cases even we can see the coordination compounds also. This type of compounds are called coordination compounds, in which this is called central metal ion, which act as a Lewis acid, and all these are ligands which readily form a dative bond with the central metal ion, and these are acting as a Lewis bases. Okay, that is all about Lewis acid base theory. So that is all about the first part of the ionic equilibrium. If you really like the video, please like, share and comment to reach many of the students like you. Okay, thank you.
Hope this time the voice is clear. I'll check and I will upload. Thank you.